Over 40% of the average American household's energy budget is spent on a single continuous task, controlling the temperature of your home against the volatile weather outside. But there is a system that can cool an entire building to a comfortable 70 degrees in the dead of July, while costing up to 70% less to run than a traditional air conditioner. It requires no complex outdoor machinery, relying entirely on the Earth's ambient thermal stability. Under independent testing, this approach, the geothermal heat pump, has proven to operate at efficiencies up to 400%. This chart compares that massive 400% operational efficiency directly against actual market adoption. Despite completely outperforming conventional cooling systems across every metric, a disproportionate 2% of American households currently use this technology. If geothermal cooling is objectively the cleanest, most efficient climate control system ever devised, we have to ask why the ultimate cooling technology remains practically invisible. The engineering flaw in standard heating and cooling lies in the physical medium it relies on, the sky. Outside air has remarkably low thermal mass, meaning its temperature fluctuates wildly. The ground beneath our feet, however, is dense, highly conductive, and completely stable. Because soil is incredibly thick, it takes a tremendous amount of time for thermal energy to migrate downward, a physical principle known as phase lag. By the time you reach 6 to 10 feet underground, the dirt completely forgets the daily weather, anchoring itself to a permanent, stable 50 to 55 degrees Fahrenheit year-round. To understand why this matters, we have to look at the basic law of climate control. Air conditioners do not magically create cold air, they simply move heat from one place to another. This graph plots the temperature difference a conventional AC unit fights against. When it tries to cool your home on a 100-degree afternoon, it has to extract heat from a 75-degree living room and force it out into that scorching 100-degree atmosphere. It is an exhausting, uphill mechanical battle against the natural flow of thermal energy. A geothermal system flips this dynamic. By taking that same 75-degree indoor heat and rejecting it into the cool 55-degree purge, the heat flows naturally toward a colder medium. The thermodynamic resistance drops to near zero. Conventional air conditioners force mechanical pumps to fight a losing war against the sky. Geothermal systems simply partner with the natural physics of the Earth. Early thermodynamics engineers in the 19th and 20th centuries actually knew the ground was a superior thermal reservoir, but the hardware of their era couldn't keep up. The seals and refrigerants available at the time simply could not handle the immense pressures of being buried deep in the dirt, forcing the industry to default to an air-based model. That material limitation was permanently solved in 1979 with high-density polyethylene, or HDPE, piping. This chemically inert plastic allowed engineers to circulate fluids through the Earth indefinitely without rusting, leaking, or degrading. With the physics and materials solved, the roadblock shifted to economics. Digging deep trenches or bringing in specialized drilling rigs for vertical boreholes pushes the upfront consumer cost of a geothermal installation to anywhere between $15,000 and $40,000. The residential solar industry bypassed massive upfront costs using third-party leasing models, where a company installs the hardware for free and leases power back. But strict U.S. tax codes have effectively criminalized this exact business model for geothermal energy. Under a specific IRS regulation known as the Functional Interdependence Rule, a utility company cannot claim tax credits or depreciate the cost of buried geothermal loops. The tax code classifies them as limited-use property because a pipe buried underneath a lawn cannot be easily repossessed if a homeowner defaults on a lease. A century-old material limitation evolved into a rigid, outdated tax structure, keeping adoption locked at 2% long after the engineering hurdles were cleared. The current approach to geothermal relies on an inherently flawed strategy, asking millions of individual homeowners to each drill highly specialized $30,000 holes in their own backyards. But a legal and structural pivot is gaining traction, especially in dense urban environments like New York City, where individual drilling is physically impossible. They are called thermal energy networks, or TENS. This diagram shows a neighborhood-wide thermal energy network in action. Instead of individual, isolated loops, a continuous network of ambient temperature pipes connects entire city blocks directly to the subterranean dirt. Because these pipes operate at the ground's natural 55-degree temperature, there are zero distribution heat losses. This creates a circular energy economy. When a commercial grocery store rejects heat from its refrigeration units, that thermal energy isn't vented into the sky. It goes directly into the shared underground loop, where a residential house down the street can pull it right back out to heat its water. Legislation like New York's Utility Thermal Energy Jobs Act is allowing gas companies to pivot their business models. They are recognizing that their true infrastructure asset isn't the gas itself, but the network of pipes they already know how to maintain. By treating these underground loops as public utilities, they can absorb the excavation costs, removing the $15,000 barrier for the homeowner. True engineering elegance isn't a high-tech gadget. It is recognizing the Earth's thermal mass as a piece of shared public infrastructure and changing our laws to finally plug into it.